Thank you very much, Roman. Well, first of all, a brief introduction. He's David. My name is José. And this we brought here is part of our lab. It's full of wires, so let's be careful. That equipment we brought along today we'll explain in a minute. So let us start our talk by saying what the goal is, okay? Our major goal today is to settle a debt that we had. We said that we will be presenting on a number of things that we were hoping to do, and we will talk about those now. It seems that this is a good year to settle some accounts that we had from the past. Some are still pending, and those issues we will try to settle for this year are the ones we mentioned back in 2014. We said that they should be possible, at least in theory, and it's just four things. Four attacks that we had launched on 2G networks by using the fake base station technique. We thought that they should be feasible in 3G, and we'll show you the results today so that we can settle that old account. Launch those attacks in real time. If they don't work, we can show you the video clips. The four attacks that we want to prove are feasible over 3G are MC catching, device geolocation, even when they have those functionalities switched off, selective and persistent denial of service, which was possible in 2G, and which we will try to prove in 3G, and then selective downgrading in 2G. With fake base station, you can do completely. You can take full control of communications over 2G. In 3G, this is not the case. But the technique would be forcing the telephone to go down to 2G and then doing the fake base station attack. We'll show you what we've done in all of them. So the first one we'll focus on is MC catching on 3G using only 3G. So before going to the specifics, you probably thought that this would be a talk. It is not a talk. It's actually two courses together. A course which is 120 seconds long with an ID and a login into the system, and another course in cryptography of mobile systems, and then we will continue with the talk. Are you ready? So, ID and login in mobile communication. In our handset, we have a SIM card which allows us to make phone calls that are then charged to you. What the SIM card has inside, I'm simplifying, okay, I only have 150 seconds available. The SIM card has the IMSI, which is the user identifier, okay, and a key, a secret key, which will never leave the handset. The user ID will leave the mobile phone, obviously going to the network, whereas the private key will never leave the card. The card was recorded there by the operator. It's on the key. It's unique for that card. And there is a copy.
It does go to the central database server. It configures the setting. The model says I'm this MC goes to identifiers. This is it about identification. Authentication works as follows. When you said I am this, the MC sent, you have to prove that you are that MC. So the same to the mobile, the same without sending the password, computers a response which is received by the network, which means that the private password is contained inside. So they have a password. They can verify you are the real user. On 3G, this mechanism and response works properly on the other side. It's not about mobile sending a challenge. When the network sends a challenge, it's also send another code or number that proves that it knows what is the private password. In this case, the mobile receives from the network this, and it validates if the other side knows the cache. This is bidirectional authentication on 3G that isn't doesn't exist. It exists on 3G. So the false base station implies that the mobile phone didn't know if it was false. On 3G, it's impossible to do directioning, so this is an error. So let's prove how many things they can do with a false base station on 3G, even though the cryptography is not broken. The course of cryptography on mobile phones, 36. On 3G, we use an algorithm of ciphering, which is 3G, which is absolutely is broken, can be absolutely destroyed. On 3G, we use 3, and these cryptographies are not currently broken. What is protected on 3G is it doesn't care, but on 3G cannot be broken in principle. And in spite of there is bidirectional authentication and we cannot break the cryptography, these four attacks can be executed. This is the last of these courses. We're happy. IMSI catching. I am the attacker. I'm trying to collect the IMSIs from mobile phones surrounding me. I would like to have an inventory of those people coming to the routed. So I switch on the base station. It's just a hypothesis. By the way, we didn't do it. It's a hypothetical example. We're going to do it inside the Faramay box because we don't want to go to jail and the soap thing is not good thing. So there are some attackers who like doing some. It's a false base station. I'm able to catch in and collect all MCs from everybody. I will play around about who is any subscriber, so you can have the inventory of those coming here and other places. You can follow this idea. You can do so with 2G. With 3G is also feasible. On 3G, I need a false base station, which sets up everything, and we configure it in such a way that the modules around it can demand a service from this false station. For this purpose, we are going to use a radio device defined by software, a URSP, and for the characterization, it's connected through USB to a PC. And for the characterization, we're going to use a Samsung Galaxy S2, an old one. With this application, it allows you to connect onto the PC and send all the frames this mobile phone is receiving. We can listen to the radio electric space, and as you can see now on screen, we can collect the missing data. We're not going to go into details. There's so many real stations around, and this is the way we can configure the cell to make it similar to some of the real ones. Up, you can see the code moving and running. The log messages had been inserted by default by us. Down, you can see a dirty script which patches this. So this tells us the information collected, and setting up a suggestion as to configuring the cells within this real environment. This would be a good configuration, but this does not apply to a laboratory environment. Should you be interested in doing it really, this could be sorted out this way. We can do it so with a sniffer. A sniffer is the longest way, which is put aside. I would like to tackle it, but this solution is just slightly sloppy, but is the way we can deal with what we call characterization of the radio electric space. We can do so with this mobile phone. It's a Samsung Galaxy S2 connected through USB with X-Gold mode. The signal message from the stations, this is receiving service, go to bypass, and the parsing is doing this way. So we got the first base station is characterized with these parameters, and let's configure the first base station and let's start giving services. We told you there's bidirectional authentication. On 3G, cryptography is used to protect almost all messages. Cryptography is not broken. Following this rule, you look and look and look, and there are some messages that are permitted without cryptography protection. Among these are identity requests, the base question. Tell me who you are. Tell me your MC. This message is not protected with cryptography. It makes sense. It's not protected this way because cryptography is established afterwards by deriving the pre-sure MC key. If we don't know what user we're talking to, we cannot use what code to use here. All these initial messages. This is mobile on the left trying to obtain service. That would be the base station. On the other side we can find the central station. It asks for a radio channel anonymously assigned, sending a superior message level. And please, I want to have a service. The network tells him back who you are. Please identify yourself. Tell me your MC, which is sent to the mobile phone. Mobile phone acts, and now we'll do authentication. We'll accept it, but we are not going to do this because it doesn't care here. Further down, we establish the ciphering. Once authentication is done, everything is ciphered and encoded and encrypted. We are only focused on the MC. We don't need cryptography. In the brain, we send a refusal message. Who you are? I want service. I'm Mr. Doe. Refuse, and it was looking for another networks. The phone device won't feel bad about being refused. So here we got everything. The MC from this mobile phone, which is around my area, and we're waiting for another mobile phone asking for service. This is it. Goes in. Let's see it live. Let's firstly see the setup. Do you want us to send what we have set up? Please raise your hands. Do you want us to show you this demo? Please. So take your camera. Just a sec. It's like a flying saucer.
Bueno,
Igual es
esto...
demasiado, ¿no?
¿Eh?
Que igual es demasiado zoom, que no se ve.
Don't zoom in so much. I'll try to show you around. It's difficult. About the Faraday box. This is a Faraday box. You can only see the lights. And this is the inside, the guts. This is a camera. Turn around, please. You can shoot at this side. Let's turn around now.
Caja de Faraday, ¿se oye? Esto es metal, está conectado a tierra y cuando lo cierras es un espacio, es una caja que cierra un espacio radioeléctrico dentro y deja aislado el de fuera. Entonces, la idea es que no pase radiación hacia adentro, no pase ondas electromagnéticas ni hacia adentro ni hacia afuera, y entonces lo que sucede dentro no estamos invadiendo, no estamos emitiendo en el espacio externo. Ahí dentro lo que hay es un... A ver si consigo verlo. ¿Esto se ve así? A ver, más lejos. Igual sí, más fácil así. Aquí lo que hay, esto es como una incubadora de estas de los niños, que tienes un guante.
You got the glove. You got the glove in this incubator. In this Faraday box are metal glove. So everything is okay. And there's a camera inside. This USB camera is connected with USB connector, which is going outside this way and goes. It's not the camera you can see outside. The camera is from above. When we are shutting down these soundproof, noise-proof, totally isolated Faraday box, inside we can, on the corner there are two antennas. From these antennas, some cables coming out that are going into this Chinese box with a chip. It's a chip board which is USB 200, which is bought on the internet. It is a multi-purpose equipment for radio communications defined on software. This is connected on USB 3.0, and on this mobile phone, the base software is running, is modulating signaling once and again from the air, and all the process, which is mobile communication, is on the PC. This is a switch, the usual switch, a Ethernet, where the two PCs are connected, and you can control the whole PC. And the three webcams can show the PowerPoint, the puts to managing the whole thing, and this is the one you can see projected over there. I didn't miss anything outside. This is the camera we have used for showing around this Faraday box, soundproof and radio-proof Faraday box. So you can see now the telephone when it's outside. Let's not mess around with this mechanism. I forgot about this. Brilliant. So you can see the engineering mode telephone with the Samsung Galaxy Asterisk, and you can see the whole information about the cells that are located. If you Google it, some of them can know the engineering code and can show you everything. With this camera, you will be seeing what is going on, and the moment it's put inside the soundproof, radio electric proof isolated Faraday box, you can see what's going on. So let's turn off the lights inside. This is the mobile phone in and out, in and out, in and out. We should bring over puppets. Puppets and Muppets inside. No, just kidding. Is it working? The MC Catching is working? Like I said, this is a simulation hypothetical mode. This is not legally permitted. This is happening inside the Faraday box. So I'm going to show you about what is happening inside the radio base station. This is not relevant for this purpose. This here we're not using the configuration we mentioned. That the prettiest one, it doesn't care here. We start and boot. What's going on here? This command frees and empties the log file and boots the false registration honestly. If you boot the UMTS as such on the web, this does MC catching, period. This does MC catching. If you are configuring your cell properly, this cell does MC catching. What happens here? We have modified the UMT behavior to speed it up properly. The dialogue between the mobile phone and the radio station until capturing the MC is quite a long one. So if it's going through the MC capturer, someone and is not enough time inside the reaching or the scope is lost. So this way is more efficient, and we are booting and starting a compilation with this previous modification that is done this way. We boot and a script that is done on the log to get the MC totally. Let's put it inside these Faraday radio electric isolated proof box. Nothing is coming out of the box. So let's do the put and out. We hope that some 6 decimals, there will not be any problem. So let's put the mobile phone inside the place where is the full cells, even service, and see what's happening. the funny thing about this demo is that let's remove the engineering mode. This funny thing about this demo is when it doesn't work inside the cage, it does not work. But sometimes outside this cage, it's working always. It's working always.
Bueno, ¿veis ahí el IMSI?
Can you see the MC inside? MC County, MC County. We got it. We got it. This is it. Period.
En la pantalla
On the phone screen, you can see the user about how on my head I've been suffering MC catching, MC catching. That's the funny thing. The phone, the telephone, this device shows the coverage. Sometimes we go as nuts. Why is showing coverage? Because the phone device, even though the cell is not giving service, given the fact that the emergency calls are thought to be emergency calls as such, the phone device think it can be an emergency call. If you are in a country where the MC is not valid, you are going to be able to do MC and emergency calls. But the report of what the phone is showing is slightly deceiving for us. I start the base station, so you can go out in tranquility. Our phone is outside. It is soundproof and radioelectric proof Faraday Fox MCKG as such on 3G. In spite of the regulations establishes bidirectional authentication and cryptography is not broken, it's feasible, no problem. Next attack on geolocalization. To sum up, for those not attending, I don't know what happens. 3 years ago, the year we presented it, we embarked on a 2G space station on the vehicle, and when the victim terminal connected to this base station, it calculated its position. In the very end, you knew what the position of this terminal was. At a certain moment in time, we set up on 3G and 2G, there are protocols to ask the base station what your position is. This can be superfluous, but you can ask your mobile phone what your position is. What should I do with all of this? For a terminal, for terminal handset, which does not modify this, okay. But is this more important on 3G? Because on 3G, as David says, we cannot accept that the handset phone. But in principle, we cannot use these functionalities about asking the mobile phone its position. So this 3G technique is absolutely indispensable as to implementing this attack, because we measure and gauge different data to do triangles, to triangularization. We can establish a radio channel called silent core, which is this radio channel established with the mobile phone, and the traffic is flowing, and this flowing traffic allows us to extract data to triangularization. Continuous flow of data. If this connection went down, we should have started again. The difficulty doing this on 3G, this data to be extracted from 3G communications? We didn't know this. We measure and gauge the frequency we can obtain this data. This graph you can see on screen shows us when we receive a data we can measure. This is shown for the Excel spreader to show that the graphs. This is the very first approximation. A base station is working. The mobile phone tries to register on that base station. On this graph, you can see signals that can allow us to do triangles, and then 7 extra minutes not registering. So it's trying on and off registries on this base station. Geolocalization is feasible. When you get on a car, but by then you don't know where to move, with the next 7 minutes, it seems to be slightly, or not too much efficient. So it's a super easygoing technique. Instead of having our registration doing this, when the registration is going to give us about the localization of this station, will turn on with a different identity. The mobile phone, instead of waiting for 7 minutes as if it's a new cell, it will try to register itself quickly. So these are the data we got. As you can see the system on screen, we are about 1 minute receiving data for triangulation and 2 minutes without receiving data. And we consider it to be enough. We have still some ideas we haven't implemented properly to make it a continuous flow, but it seems to us, even though the process is slightly slowed down and the precision increases a lot with the number of samples, the precision of the system reduces a lot, but the results are very similar to 3G. But this data make us think that geolocalization by extending these features to 3G is feasible as well, and we remove the takeoff. We think that because we have proof to be true. We're still to remain ones. Persistent denial of service. Is it possible? Denial of services within wireless communication is always feasible. Whether you're talking about Wi-Fi, mobiles, if you want to deny the service, the only thing you need is to connect yourself to a frequency inhibitor. The bigger the better. With a frequency inhibitor, you can stop and interrupt the communication. This is presented for 3G, for 2G some years ago. The columns are characteristics. The frequency inhibitor is a massive attack. We turn on a jammer here. It affects everybody. We cannot discriminate who. We cannot make it selected, persistent. When it's turned off, when it's turned on, there's no service. When we turn off the jammer, because we can run away from the police, the denial of service stops as well. And it's transparent to the user. You see the mobile phone, I have no coverage. We don't get into that. We don't go into the next intermediate attacks, but let's focus on this one. The LUPRCC technique. Procedure course code is the refusal code. We did it for 2G, and these videos are ready to be seen. These attacks massively with your inhibitor. You can select with your inhibitor who you want to attack. This LUPRC is persistent. If you send it to the right code, the mobile phone is silly, is totally dizzy, and the user has to turn off and turn on the mobile phone if he wants services. If you put it on flight mode, it starts waking up. But the other one, with persistency, you need to turn it off and then turn it on. So I need to reboot the phone. And transparent to the user depends on what mobile. Some mobiles will tell you, I have no service. Other studies, I have service, and you start calling, and there is limited service. It's based upon location update procedure, you reject cost code. There is a dialogue. Who you are, I'm asking for service, and we refuse it. When we refuse it, we can indicate what is the cause of this refuse. Is congestion. So MCM no, in HR, illegal MS, PLM not allowed, location area not allowed. So the regulation says that I am a stolen mobile phone, so brilliant. I'm not trustworthy of having service, period. And it has to be out of service until the user turns it off and off, period. Until the user asks for service again. So we could do this on 2G, and now it's feasible as well on 3G, and I'm going to prove you now. So as follows. In order to check it, we need to make sure that the refusal code sent by the base station, but very first we need to export the IMSI. We receive it with the IMSI catching, and then we decided to be refused. We can do it for one IMSI for the whole amount of IMSI. We need to change the configuration of UPTMS in order to send the correct refusal code. So let's tell this mobile you are illegal. So let's boot this version, compile with this version, which is a modification of Open UTBS, as David says. We boot it. We are signaling inside. The mobile phone is outside. Please, let's put it inside. Once again, within this radioelectric proof isolated Faraday boxes. This is a hypothetical experiment. So far, so good. It's perfectly arranged. Should be lucky. Oh, by the way, I forgot about reconfiguring the cell. It won't take me a lot of coverage. It's coming here. It's coming here. We press reject routing area update reject message. It's a log message, which means this mobile phone has no coverage at all, but even though it's showing it has coverage, but it doesn't have coverage at all. So I was told the base station, I'm not signaling, I'm not emitting any of the signals. Now we are emitting, no problem. It didn't happen anything. Somebody from the first row would be stopping receiving 7. So this demo was conducted on 2G, but it's now conducted on 3G. Let's wait for catching the coverage. Let's see what happens with this mobile phone inside. The mobile phone has no coverage at all unless we put the system on flight mode. Sometimes stopped having service. Here on engineering mode, it tells me, okay, I have no coverage. So UMTS limited RRC state idle, WCDM. When you are in a supported mode, and you cannot read limited mode, this is to verify that it has no coverage. Let's try to call any number from here. The phone cell. This is a random number. I'm pressing 3, 6, 8, 5, 6, 5, 6, 5, 6, 5, 5. No it's not. I'm not registering the network, even though it's out of the cage. That's what the Faraday box. It should have coverage, but the mobile phone says to me, okay, I'm not registered in the network. I think it should pop up a sign saying, I am not trustworthy of having service because you are a dumb thief. Let's put it on flight mode. Let's see if it gets service. Let's turn it on and turn it off. With flight mode is enough. Plane mode. Let's turn it off and let's move on to the next demo. Adjustments press, sim button. Now plane mode, accepted, plane mode. The plane is on screen. The sim applies with the right button. Flight mode, it should be deactivated. Let's make it convincing about it's trustworthy of the service.
So now, it can call now. There's very little time left. You believe the service is there, isn't it? This is unusual. Well, if the user has a mobile phone in his pocket, he will realize that they have no service. So denial of service can be done over 3G because there is no need to breach into the cryptography. And 3G is just like 2G. A scenario would be like this. You want to do denial of service in a certain area, The first thing, you buy a car, you use an antenna on the roof for good coverage, and you drive around and you keep applying it. You do denial of service for everyone. Those that get denial of service have a dumb handset, and that's it. And another scenario, another practical application. If you want to get rid of coverage for mobile phones in a certain area, for example, if you want to stop mobile phones from activating devices, if you use a frequency inhibitor, it inhibits everything, including your own mobile phone. But if you go around the area and you broadcast that code, you just inhibit those mobile phones you're interested in. I mean, trusting this device for everything, that would be too far-fetched. But anyway. So, in 3G, this is possible, in short. We now move on to the last one. The selective downgrade to 2G. To do 2G downgrading, selective 2G downgrading, we can use a frequency inhibitor that injects noise. The higher the power, the better. So it inhibits the legitimate signal, injecting noise, so your mobile phone doesn't connect to the base station. This is for 2G, basically. But it's got too many problems. The range of this technique. 2G and 3G are quite robust in terms of endurance towards noise, so you need to send a signal which is very strong. And then inhibitors use the entire frequency range, so you need a lot of power. An inhibitor with a certain range is this big, as I have been told. Anyway, we don't use it, it is illegal. And there's other problems, there's weaknesses, consumption, dissipation, and then your own signal might be in another band, and yet you will be affected, because unless they're very expensive, they have low quality filters, so they don't really distinguish between different bands. They affect telephones in different bands. Quite cumbersome to do downgrade. And there is another problem. Usually, inhibitors inhibit full bands, like the frequency at 900 Hertz. In Spain, we use 900 Hertz for GSM and 3G. So if you want to inhibit 3G, you need to go for 900 and 2100. So there's no space left for 3G. So it's quite cumbersome. For certain practical applications, it might be okay. But if you want to do selective downgrading, there is a much more elegant choice, which is the one we will see. Let's imagine the attacker has two base stations. In a real environment, they would have two base stations. One is 2G, one is 3G. In the 3G base station, what the attacker will do is when they get a level 3 connection request, an RRC connection request, bear in mind that so far we've seen them at the level of the mobility. I have a radio channel allocated to me from the base station, and I use it to say who I am and so on and so forth, but I had a previous channel there. So we move down. The handset doesn't have a radio channel allocated, not yet. The message coming always, and I've never seen anything else, is RRC connection setup. Here you have a radio channel. There's no ID, there's no authentication, there's nothing. You cannot identify the handset. The handset is not yet requesting a radio channel to speak to the base station. This is a significant difference. Here we cannot identify the handset, so all the messages that we've seen coming after RRC are RRC connection setup. Here you have the radio channel. I'll see who you are and then decide whether I will give you a connection. But with this software, it doesn't implement a reject. It never gives a reject. It is not implemented. It always accepts the incoming request. Here you have your radio channel. We'll talk later. Instead of accepting, we will be rejecting. Okay? There are only two codes, 0 and 1. 0 is congestion. I don't have a channel for you because I've run out of channels. And 1 is a generic one. Others. There's no way to determine what the reason is if you give a 1. So with that reject message, there is a possibility in the protocol, which is what we read some time ago, that allows the system to say, I don't have radio channels for you, but I have a little friend over there. I know another base station that can be 2G or 3G that does have radio channels for you. So go and ask them. Go and ask the other cell. So we do give the user redirection information. I don't have a radio channel for you, but this base station with this frequency does have a radio channel for you. So we redirect, and the handset goes all the way over to the 2G base station. At this stage, there's something missing. What is missing? We said that this is selective downgrading, and we said that we cannot identify the handset. That selective functionality is carried out at the 2G base station. The 2G base station says, who are you? If it's the IMSI we want to capture because it's our target, we accept it. If not, we reject it. So you need to get a legitimate signal from another base station. That is how the system works, the technique works. Before we show you the demo, okay, we'll be playing tricks. It's going to be very quick. We'll show you what you will see before you actually see it. We need to do it fast because we do the demo in the cage. Outside of the cage, the demo is really powerful. What we will see in the demo, if it works, if not, we will show you the video. We have the handset operating in 3G mode. Okay, by default, I have 3G, so I use 3G. Otherwise, I'll go to the 2G. But if he has a base station on a 3G, it will be talking over 3G. We'll see this later. So we turn on the base station inside. I'll say, go now. David will introduce the handset into the cage, and that dialogue will take place. So we'll send a reject message. Here we will not say what cell it is. We will just say, go to 2G. When we see that message on the screen, I'll tell David, go. So he will take out his mobile, he'll leave it outside and let it go for 2G. We will see that for a few seconds it will be in 2G and then back to 3G because he will get legitimate service from 2G. Okay, he will get a legitimate signal. If the base station he was connecting to was the attacking base station, the handset would remain with that base station because there's no neighboring base stations. The service is only 2G from that base station. We haven't done that demo because when doing this, the handset can lose the coverage. It goes to the 2G base station and it is a shitty demo. So it is more realistic to do it the way you're going to see in a minute. Let's go. For the time being, this is here with legitimate service on and 3G. We'll see that that's all. Normal 3G service with one of the base stations around here. The operator it is connected to, we're using SIMs from, I can't remember, the operator. This is not specific for the operator. It has to do with the standard. Okay? So what we do is to start our base station where we have implemented that message. I'm here ready with Control C, and David is ready with his finger to take the handset out, to take the handset in, sorry. You can take it in when you like. So here we go, handset going in, there it goes. We don't see it, it's me, right? This is the time.
¿Le has cambiado la identidad?
You've changed the ID for the cell, for the base station? There it goes. Now, that's it. Remove it now. There it goes. If we don't take it out quickly, it believes it hasn't found any 2G service. So let us check. It takes a few seconds for it to find, to search for a 2G service. I think we were not quick enough. It's hooked up to 3G again. It's 3G. Okay, let's try it again. It's because of the cage. Okay, we'll try it again. I'll change the ID. I was too late telling you to go. Okay. Okay. There it goes. In. It could be that 2G coverage here. We checked it yesterday. It might be a problem with coverage for 2G. It's a bit poor. It did work before. That's it. Go, go. Sorry about the rush. Fingers crossed, everyone. Yeah, got it. There it goes. And since it's worked, let us enjoy it for a second. Despite having 3G service available out there, the handset has decided to go down to 2G because it has been told to do so. Obviously it goes back to 3G. But when redirecting, you can force it to stay for 15 seconds on 2G. That was the time it spent on 2G. But as I was saying before, if that base station, instead of being a legitimate base station, the handset would remain there, because it would be told that there are no neighboring base stations available, so it would remain in 2G. Here, even if we have 3G communication available, an attacker can force, without a denial of service, the attacker may remain undetected, and they can force the handset to go down to a 2G service, as you can imagine. As you have seen, when we said reject, we stopped the base station. After doing the reject, you can stop the fake base station for 3G because you've got the handset in 2G. So 2G service allows for full control of communications. So it's an attack with a relatively high impact. And that's it. So we don't believe it is feasible. It is feasible, and we've demonstrated. So once it's 2G, you can do everything. You can hook onto it. You can do a wiretap and listen to everything they say in their conversations, because it's 2G. What can we do against this? Countermeasures. As users, very little. As manufacturers, well, in theory, they might include an option to get rid of the 2G service option altogether for handsets. IMSI catching would still work. At least you know that you're not going to be downgraded to 2G to hook onto your communications in 2G. We have a little chart that gives a summary of the countermeasures and the attacks that are possible. They might warn users when service is 2G, so that the user knows that 2G is being used. And if the base station tells the handset not to use encoding, the handset might tell the user about that. In the past, there was a warning icon on the screen, but then there are so many users out there that wouldn't care about this. But this should be an option. The manufacturer might send a warning to users and about extremely unusual messages. Like, for example, you're an illegal handset. There is no reason whatsoever for a legitimate operator to send a reject message to a handset, unless I've stolen the handset, of course. But for normal users, that should never ever happen. There should be no blacklist. If I get a reject message, that is so strange that there should be a warning. And the same goes for the reject message. Redirecting. Oh, I'm not giving you 3G service, but go down to 2G. That is very strange. Perhaps in some remote areas that might happen, but that is very strange. As users, what can we do? Well, we can deactivate, disable 2G. If you have no 3G coverage, you might get off the network. Obviously, there could be a deployment of detection systems to detect fake base stations. If a base station comes along with a strange configuration, well, for domestic users, you wouldn't use a detector. But in a large company, where you have lots of mobile devices for the executives that you cannot afford having hooked on, it might make sense to have a detection system in place so the company can detect when there is a fake base station. It might be an interesting choice. And then, as users, we always have the freedom to cry out demanding that we need changes in our handsets. If we don't demand new functionalities, if we don't cry out loud, if we don't say anything about this, the operators and the vendors will do nothing. We must put pressure on them, because it's a waste of time for them if there's no demand from the public. So one recommendation would be to put pressure on them. And this is the little chart that I told you about. For all of these recommendations, including the selective downgrade, for IMSI catching and geolocation and persistent denial, this is what you would use it for. Especially alerting the user when there's something strange. Obviously, it's up to the user to switch off the handset or not. And then detection systems. And this is 3G. But this is a thing of the past. We have 4G. What happens with 4G? Well, it's in the to-do list, because time is a very limited resource and we haven't had the time to get into 4G. But what our gut feelings tell us, we haven't actually read the standard, every single detail, but it's quite likely that it's possible to attack 4G networks. There is something we know about already, but IMSI catching for 4G we've tested already. Someone published information about this in Europe, and we've tested it in our lab, and indeed. What happens before using cryptography? Well, in theory it's going to be the same as for 2G and 3G.
Nosotros, del código de rechazo y etcétera, etcétera, pues hay que leerse la norma para ver exactamente qué códigos.
So we need to find out about the reject codes and everything. But we haven't tested it, so we wouldn't state anything, for sure. And then another open question we're concerned about is about the implications of the eSIM cards. You know, so far we have been using physical SIM cards. If you change to another operator, you need to remove the old SIM card and get the new SIM card in. Now after the MWC in Barcelona, they've been talking about eSIMs that are fully electronic. So you have something, a piece of software in your handset that will allow you to store new identities for other operators, and the device will be able to switch between one and the others, depending on who is providing the service at any point in time. We don't know what level of security they will offer. We haven't seen the details yet. And this is what we were here to tell you about. 3G, we've made it possible.
Muchas gracias. Si tenéis cualquier pregunta.
Thank you very much indeed. If you have any questions. I see people at the very top of the room. Can you stand up? I had a question myself. How often are logs deleted from base stations? I mean, if you connect to the base station, there will be details about your connection stored there. For how long? The answer is, for a real operator, we don't know. We don't know whether the potential legislation that requires that those logs be kept for a certain amount of time. The logs are there, for sure, but we don't really know whether operators are obliged to keep them for a certain amount of time. That is perfectly feasible, because that information might be required by the authorities or the police forces. And apart from that legal obligation we don't know about, it depends on the configuration applied by each operator, obviously, and the resources allocated. We know for a fact that they do it, but we don't know for how long the data is stored for with real operators. We don't really know whether this is stored for a long time. Perhaps it's sent to a central repository. The data is sent, obviously, is forwarded to a central location. That goes to the central location. It goes to the backbone. So it leaves the base station. But for how long they store it, we don't know. It depends. Probably varies for different operators. So it gets to the base station checks that that MC is in certain coordinates. How does it work? Well, there's different methods. You mean geolocating the handset? Well, just imagine someone has 3G, they're in the middle of a mountain, and they're hacking someone else's line. Could the operator identify the SIM card that was used for the attack and track it? See what base station they're connected to and all that? Yes. Yes. Yeah, they can. Clearly, that can be done. I mean, that is logged. For how long, we don't know. But what is logged exactly? Well, the first thing that is stored in the log is the base station the connection was made to from that handset. That gives you the location for the base station and the range. They have different ranges and they are configured for different ranges. If it's in the mountains, it's probably a longer range. If it's in the city, it's a shorter range, for sure. So it gives you a location with a perimeter around it. If the operator has implemented the functionalities in the protocol to do precise geolocation of the handset, that is optional. That is up to the operator. They may have the exact location, not just the base location and the range for that base station, but also the exact location of the handset. But that is not always implemented. It's up to the operators. Thank you very much for that presentation. A magnificent one, by the way. I have a doubt myself. With that IDS, the IDS for the fake base station, I've read some news from the Americans. It seems that they have lots of fake base stations there. Half of them are Russian. In Spain or in Europe, I've read nothing about this. Would it be worth, if it's worth to demonstrate that setting up an IDS is worth a while, there must be actual threats on the ground. Yeah, we've read about it and we don't really know much more than yourself. What we've seen is that in the US, there were hundreds of fake base stations with antennas that belonged to no operators. And then different conspiracy theories. Yeah, and drones and things. Yeah. Because a fake base station is as simple as what you've seen here. You put it on board a drone, you make it fly, and you do whatever you want to do. By collecting the images, you know who is there. Legal or illegal, that's another story. But in Spain or in Europe, we've seen nothing. We haven't seen headlines about fake base stations. They may be there, but we don't know about them. But that doesn't prove that there is no threats around us. Because anyone can operate a drone, or someone with a backpack can move around, or a fake base station like a cactus. Haven't you seen these funny plants or pine trees in rooftops? They might be fake base stations. all over the place. The threats are there, but then you need people interested in getting your IMSIs. How costly would it be to set it up, to set an IDS using a fake base station? Well, it depends on the complexity. It's just writing code, because it's just listening to radioelectric signals and then apply your own criteria. If you suddenly have a base station saying, this is me and I'm not encoding my data, that's strange. So you may define criteria about strange things. The longer your list of criteria, the better fine-tuned your search methodology will be. There are different levels to do everything. There are some projects out there based on using handsets and analyzing how the handset communicates with different base stations. There's a number of methods that give different detection levels. Some of them are very limited, but that's some better than nothing. If you want to be really good at doing this, if you want to be more comprehensive, you would need to invest a bit more. But starting with a simple methodology based on handsets themselves is not very costly. I don't really know how many false positives you would get with a simple setup. Thank you very much. Hello, and congratulations for such an interesting talk. I have a question myself. You said that from the user side, there are some recommendations. There might be warnings generated by the operator sent to users about IMSI caching or whatever. And denial of service, for example. I'd like to know what approach would be suitable at a corporate level. Perhaps communicating with the server, sending a message. Has this been implemented on a large scale? Thank you for that interesting question. I'd like to see handsets. You're right that with IMSI caching this has been done, but with the rest of the problems, even when you have denial of service, if you find out immediately, that's much more useful than finding out 2 hours later. After 2 hours, you realize that you had a denial of service for 2 hours and the bad guy has done whatever they liked. So I think it's very useful to know from minute one, yeah? But there's very little you can do to defend yourself against this. One potential defense mechanism would be the handset telling you with a pop-up message or whatever. If there is an API that could be integrated with an MDM, that would be the bomb, because you will get alarms in the MDM telling you that in a certain building, all mobile phones are under attack for a certain corporation. So that would be extremely interesting. And to the second part of your question, we don't know for a fact that that exists. We believe that that is not available. And precisely for corporations, it would make sense. So it would be a sensible thing to expect from manufacturers. With a certain combination of baseband and firmware that could allow for the implementation at a corporate level. So obviously our recommendation is to make waves about this. But making waves at this forum is very simple because you understand this. But tell your grandma to get in touch with her vendor and demand from them that they get an alert signal in their screen. They might hate it. They might be bothered by that. So it's difficult, but I'd love to have that. I'd love to have an integrated solution with an MDM platform behind, at least at a corporate level, so that we know about denial of service from minute one. You know what's happening right from the beginning. Thank you very much.
Would be possible for us to use the radio detection mechanisms in order to proceed with the denial of service attack by keeping the handset and interacting with several false radio stations? Yes and no. We would not need to rotate among false base stations to keep it on 3G, because if you don't care about moving on 2G, you can tell it, okay, telling what radio frequency do you recommend, which is your false cell. This is the 2G cell configured with the empty next door sales does not. Oh, please, the handset says, giving me service. The mobile phone receives the number of sales to be monitored, and the handset does not monitor anything. It keeps that to sell. You don't have to do anything else. If you don't want to get a 2G connection and it's saying, I have a 3G, you have to readdress it and redirection it to the 3G because it has no cryptography and you accept for this 3G and this is it. It should be working. We didn't check it, but it should be workable on 3G on screen even though it's on 2G. We know that info redirectioning and readdressing is interrupt with radio rated access technology from 3G to 2G and from 3G to 3G. So here the message works, or made work. A question over there. There is a missing question at the front row. 3G, 4G, I don't have too much. I'm talking about the absolute ignorance. I attended some conferences like this, but I know PGP, HTTP, SSL, TDS as asymmetric. On HTTPS, there have implemented proprietary downgrade systems. STC, hello, I'm google.com, don't connect to myself without being ciphered. So the browser keeps it there, google.com, never without ciphering. You go to google.com, there is a man in the middle without ciphering, and the browser would say, no, I was told not to be connected without ciphering. I'm sending you over an error because there's trying to send messages without ciphering. On the other side, I know that at the PGP level, when I'm meeting with a friend, this is my public key. It gives me the public domain key. By ciphering messages, they can only decipher with his private key. Can you implement something similar on 3G and 4G? As of today, we had powerful mobile phones, even more powerful than even the desktop phones. The base station says, takes it. This is my public key. And the mobile phone says, this is my public phone, exchange messages this way in a cipher way. If there is a man over there, this is my public key. The telephone will give you the public key without connecting with the other base station. This is ciphering between the attacker and the handset, and the phone can get a list of public keys, only accepting this. Can we implement this at the protocol level? It would be a redesigning of the whole thing. On 6G is under testing. For 7G, we have to think that we came here to attack communications, but communications, the mobile phone communications are marvel. They have problems that IP has nothing to do. One of the issues with the interface radio communication mobile phone, they try to minimize it through many things, especially the amount of traffic. If you want to implement this at ITC level to implement a radio channel, it would be an increased cost. Of course, latency. When you're asking for a radio channel, you aren't doing anything. You start the connection, you identify, and you can see some mobile communication formats that do not exist on IP-based communications, and that are a condition for the design of the communications. As David said, this is a rule coming from a long-term period. Redesigning the whole system is such a complicated issue. We don't know if it's done on 3G, on 4G. Integrity protection has been added on RSS communication. We don't know what messages have been added, but this improvement and enhance has been incorporated. We can do so, as you say, theoretically speaking, but then there are some implications that, due to the impression we have feel, they don't take it into account. Like I said, on 3G, and so I don't know too much about 3G, but I have the feeling that HTTPS is an open protocol designed to the community per se. It has obvious advantages. I have the feeling when I'm looking at 3G, 4G, 5G, it's a closed protocol. The manufacturer says, this is it, this is the chip. This is a chipset, you have to communicate, and this is doing everything. I have the feeling that is like this is like a design for other user cases that is not ideal, but the manufacturer is saying, I don't care. I'm going to implement my protocols, I've manufactured closed protocol documentation, does reverse engineering. There had been some things existing in the market. There should be logical to use this. Or you have to base your system on existing things and not just spend all the time modifying things. We can talk about during the lunch. This is not private. This is not secret. This is not closed. They are not allow us to access to the baseband on the mobile phone to modify. But once describe the protocol, you don't need to do reverse engineering of standards. The problem, there are so much information and thousands of documents you have to read, but the regulations, the norm, the legislation is public, but implementation doesn't allow you to touch. The protocol is publicly published. We're running out of time. Thank you for your collaboration.